Hey guys, this is JB from Planning Seeds Tutoring. In this video, we'll be going over the measures of central tendency and variability, which is just like an introduction to basic statistics or elementary statistics. Don't forget you can use my referral code JB20 to receive 10% off on your next tutoring package. So let's start off with this set of numbers right here. We're going to be using this set of numbers right here to solve for its respective measures of central tendency and variability, which are just mean, median, mode, at least from an elementary statistics point, and a couple of others. You've most likely seen most of these already, but let's just review over them in the case that you have. So the mean is just going to be the average value. And the best way to solve for it is just adding up all the values inside of a set and then dividing by the total number of values that you have. By the way, a symbol that we commonly use to symbolize the average or the mean of a particular set is going to be x bar. It's a straight line over the x. So x bar is going to be, in this problem, 1 plus 4 plus 2 plus 9 plus 5 plus 1 plus 4 plus 7 plus 1 plus 0 plus 3, all divided by 11, because there are 11 numbers inside of the set. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's messed up. 9, 10, 11. A generic way that we kind of solve for, a generic formula that you can use to solve for any mean. Oh, by the way, the mean that we got here is going to be about 3.36. It's 3.363636 repeating. So I'm just going to leave it as 3.36 approximately, just rounding to the nearest two sig figs, or 2 decimal points. Sometimes you might be looking for the nearest 3 digits. You might be looking for the nearest 5 digits. It just depends on how much you're rounding for. A generic formula that you can use here is going to be x bar equals sigma, which is a Greek letter. This is a Greek capital letter for sigma, and this just represents in most cases this represents addition. So if you see something inside of it, it's just telling you you're supposed to add up all these values. So sigma of I equals 1 all the way to n of xi divided by n. So a literal translation of what this says is we're going to be taking the summation of all the numbers, all these x values from xi till xn. So in this case, my xi, this is just going to be x1, x2, x3, ... And xi just represents a value for all of them. So xi equals 1, that means that's my first x value. So in this case, that's going to be my 1. Xi equals 2, it's my second value. It's going to be 4. You're doing it all the way until xi equals xn, which is your 11th value in this problem, because n just represents the number of values in total. So here, this is going to be my x11, which is my xn. So if we do that, that's going to be my mean right there. Median, a word that you can kind of associate with it, is just going to be the middle, because that's exactly what it is. It's the middle value inside of a set. Within a set, you're just placing all these values in order from least to greatest, and you're finding the middle number. And that right there would give you your median. A common symbol that we use here is going to be x tilde. We also might just use MED or M just to represent the median, but this is also quite commonly used as well. So in order to solve for the median of this problem, we would first generally want to keep all these values out in numerical order. Let's go with 0, 1, 1, 1, 2, 3, 4, 4, 5, 7, 9. Those are all 11 values here. Well, to find the middle number, let's just cross out ones on each end, from each ends. Cross out 7, 1 and 5, 1 and 4, 2 and 4. Leaves you with just 3 that you haven't crossed out yet, which just indicates that 3 is going to be your median. In this particular problem, our mean and median are pretty close to one another, but that's not always going to be the case. Sometimes you might have a mean that's very high or maybe very low, and a median that's like neither in comparison. And we generally want to use mean and medians for separate units and stuff. So whenever we have a mean, we want to use it for statistics where you can kind of expect a normal distribution, where you kind of have equal amount of people on both sides kind of getting a particular values. If you're getting a 5 on one side, then the mean is 10, then there's probably going to be an equal number of people, about an equal number of people getting a 15 on the other side. And that right there is kind of how we determine this. Generally, we have a lot more people closer to the mean, and that's when you kind of want to use mean as your main statistic. Sometimes though, your statistics may be a tad bit skewed, maybe left skewed or right skewed, which I'm not going to go over in this video. But what that would look like is if you have a distribution that looks kind of like this, or maybe kind of like this, where instead of it being popped up in the middle, it's actually all popped up on one side. Most of your data values are on one particular side. Well, that means the mean itself might get heavily pulled to the extremes because of an outlier or something. But generally, your median itself is going to represent what a majority of the people kind of think about. Majority of the values are. Mode just represents the most common value. So in this set of values, we know that 1 appears 3 times, 4 appears twice, and all the other values only appear once. Well, now based off of that, 1, since it appears more than all the others, 1 is going to be our mode. And word that you can associate with is just most. Range is going to be the difference of the largest and the smallest values. So in this problem, my largest value was 9, and my smallest value was 0. So subtracting them together, I get 9 minus 0, which is 9. That's going to be my range. And just a note, sometimes for mode, you might have multiple numbers that appear the same number of times, and they're appearing more often than all the others. You can have multiple modes, so you just label both of them as a mode. Sometimes you don't have a mode at all because all the numbers appear at the same rate. For the median, just another note is if you have an even number of values, you would just take the average of the middle two numbers. So let's say that I didn't have the 0 right here. Well, in that case, this 3 right here would actually get canceled out by the 4. And so I don't have a middle value inside of the set itself. Well, I can find the middle number by adding up 3 and 4 and dividing by 2, which gets me 3.5. That was if I didn't have that 0, but I did, so I can leave it there. Next, let's look over the mean absolute deviation. The mean absolute deviation is just a measure of variability, which tells us how much most values are on general, how far they are from the mean. So I use 3 letters to kind of describe it, and that's going to be MAD. This is a common abbreviation. And to solve for the MAD, there is a particular formula that's associated with it, and that's just adding up the absolute values of the difference between the mean and each of the values from I equals 1 all the way to n, and then divided by the total number of values that you have. So what you would be doing here is you're just adding up all the values. You're just finding the mean, kind of all of the differences between like the actual mean of the set and all of the values in the set. So a way that you can kind of look about it is going to be, well, we already know what the mean is. So it's going to be 3.36 minus our first value, which I'm just going to look at it from here, which is 0, plus, as remember, sigma represents addition, 3.36 minus 1 plus 3.36 minus 1 plus dot 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 plus 3.36 minus 9. There were 11 values here, so I divide by 11. And this right here should get me about 2.215. Now, absolute value, that just means if you get like a negative value from subtracting, so right here, 3.36 minus 9, that's going to get me a negative number. I'm just going to make that a positive value. That's all that absolute value tells me. Just tells me the distance. So it's very similar to solving mean. It's just there's like one additional step. So you already have the mean, and then you're going to do one additional step to find the mean absolute deviation. Finally, the interquartile range. The interquartile range, which is also known as the IQR, is solved by, it's the literal 50%, the middle 50% of the data. The middle 50% of the data. So if you look at like this set of numbers that we have, so once again, I'm going to use these values right here. The ones that are in order already. If we look at these values right here, we're going to notice that you can kind of group them up in terms of like there's like separate like groupings essentially. Well, 3 is going to be like the middle number. So 50% of all the values is going to be to the right of 3. That's going to be 50%. And 50% is going to be to the left of 3. Well, what you would do for the IQR is you would find the median of all those values in between that. So 4, 4, 5, 7, 9, we'd find the median here, which is going to be 5. And 0, 1, 1, 1, 2, it's going to be 1. Now, finally, what you would do here is going to be, you just find the range of this. 5 minus 1 gets me 4, so my IQR is going to be 4. So 50% of all data lie within 4 values of one another. That's what it tells me, which is true. All right, so now let's actually try solving for the mean, median, mode, range, MAD, and IQR of this new set right here. This just could represent like the set of grades that a class had on like particular test. So generally what I would want to do is actually just start off by making all these numbers in order. Let's actually do that. So it's 43, 57, 61, 61, 72, 76, 80, 92, and 95. So some students got an A, some students may have failed, but overall, that's like, this is what it looks like, all the data in this class. Well, to find the mean, which is going to be x bar, well, to solve for the mean, you just add up all these values and divide them by, you have 9 values here, so you just divide it by 9. So I'm just going to duplicate this, and instead of having commas, just have addition signs. Divided by 9, and this gets me a value about 70.78. Real value is like 70.7777. I'm just going to approximate to 70.78. my median is going to be the middle number. Well, if I cancel out all these values, I find out that my middle number is going to be 72. 72 and 70.78, they're pretty close to one another, so this might be very close to like a modern, like a normal model, but we're not going to get into that. Finally, mode. Well, mode's just going to be the most commonly occurring number, and that's going to be 61 because it appears twice. Range. Well, range is going to be the largest number minus the smallest number, which is 95 minus 43, which gets me a value of 52. The MAD, mean absolute deviation, is going to be, well, remember the equation is the absolute value of x bar minus xi over n from xi equals 0 or equals 1, or I equals 1, all the way to n. Well, this right here, just like give you a heads up here, it's going to look like 70.78 minus 43 plus 70.78 minus 57 plus plus 70.78 minus 95, all divided by the absolute value of that, all divided by 9. And this should get me about 13.58. Finally, to solve for IQR, well, that's just going to be my middle 50%. And let's actually try looking at that. Oh, well, my median is going to be 72. We just solved that. So I'm looking for the middle value here, which is going to be the average of 80 and 92, which evidently is 86, and the middle value between 57 and 61, which is 59. So you would subtract 86 and 59 together to get you 27, and that's going to be your interquartile range. The middle 50 numbers are within 27 values of one another. All right. Another thing real quick to note is that the value right there is going to be called like a quartile number. This right here is going to be quartile 3, Q3. This right is going to be Q1. So IQR in general is always just going to be Q3 minus Q1, the value of that. Yeah. But with that, that's going to be it for this video. I hope you guys learned something new, and thank you all for watching.